Hello everyone, and welcome to Earth Archives. So, you're saying there's a chance that Uranus and Jupiter, two completely different gas giants, could actually collide head-on? That sounds like something straight out of a sci-fi movie. It feels almost impossible, doesn't it?
When we talk about the possibility of Uranus and Jupiter, these two massive gas giants colliding head-on, many people might think it sounds like a scene from a science fiction film, full of dramatic tension. But in the real universe, the likelihood of such an event is extremely low. Both Uranus and Jupiter are steadily orbiting under the influence of the Sun's gravity, each following a stable and well-defined path. Their orbital trajectories are relatively fixed and not prone to sudden, extreme shifts, unless there's some external force involved, such as the gravitational interference of another massive celestial body. It's highly unlikely that Uranus's orbit would shift dramatically enough to bring it into a collision course with Jupiter. That said, astronomers haven't ignored this extreme, yet intriguing, hypothetical scenario. Using advanced computer simulation technology, they've attempted to recreate what a collision between Uranus and Jupiter might look like, in order to gain a deeper understanding of the astronomical effects and changes such an event could trigger. These simulations aren't just theoretical exercises. They're powerful tools for exploring potential crises in the processes of planetary formation and evolution. A collision would release an enormous amount of energy, causing the gas layers of both planets to violently merge and compress, possibly forming a new, massive gas giant. It might even alter Jupiter's rotational speed and magnetic field structure. This kind of simulation research is crucial for understanding the stability and future evolution of our solar system. It helps astronomers predict potential risks of celestial collisions and deepens our understanding of planetary physical characteristics. Although the chances of such an event actually happening are incredibly slim, exploration of the cosmos should never be limited. After all, the spirit of science lies in curiosity about the unknown and the constant pursuit of new challenges.
Wow, so just how intense would this cosmic collision be? What I'm imagining is like two giant balloons crashing into each other and exploding into pieces. Is that what would happen?
Saying that Uranus and Jupiter would explode into pieces during a collision isn't entirely accurate. After all, these two planets are primarily composed of gas and ice. They don't have solid crusts like Earth, nor do they contain oxygen. So we wouldn't see the fiery, explosive scenes we're used to in movies. Instead, when these two massive gas giants meet, the moment of impact would generate immense pressure and extremely high temperatures, causing their gaseous layers to violently compress and merge, more like two enormous balloons being squeezed together into one. In such a collision, Uranus's outer layers of gas and ice would likely be stripped away by Jupiter's powerful gravity. These materials could either be absorbed or flung off into the depths of space. Meanwhile, Uranus's relatively denser and colder core might be torn apart or partially pulled into Jupiter due to its gravitational pull, potentially forming a new, more complex celestial body. This new object could surpass Jupiter in both mass and volume, yet still remain a gas giant rather than becoming a true star. In short, this collision would resemble a dramatic fusion and rearrangement of gases, rather than an explosive destruction. Uranus wouldn't shatter into fragments and vanish. Instead, it would undergo violent stripping and deformation. Its core might be partially preserved or swallowed into Jupiter's interior. This process showcases the unique physical nature of planetary collisions in space and offers a stunning look at how gas giants can transform and evolve under extreme conditions.
Sounds like Jupiter is an unstoppable overlord, capable of tearing Uranus apart. But what about Jupiter itself? Wouldn't it take a beating too?
That's a really fascinating question. Jupiter's mass is vastly greater than Uranus's. So in a collision between the two, Jupiter wouldn't be easily destroyed like an asteroid might be. On the contrary, the impact would cause Jupiter's thick gaseous outer layers to churn violently, almost like a massive storm erupting within the planet. At the moment of collision, enormous amounts of gas could be forcefully expelled, creating spectacular plumes that might even be ejected deep into space, an awe-inspiring astronomical phenomenon. Additionally, the collision would trigger a redistribution of energy and materials within Jupiter. Its normally stable atmospheric layers would be violently stirred, and the extreme pressure and temperature inside could be altered as a result. This internal reorganization would make Jupiter's structure even more complex. What's even more intriguing is that the impact might change Jupiter's rotation speed, and even its powerful magnetic field could be reshaped, causing a ripple effect of magnetic fluctuations. Still, despite such a violent interplanetary collision, Jupiter would not be destroyed. It would likely become larger and more unstable, like a giant that's weathered a cosmic storm, continuing its orbit through the solar system with new scars. These changes could alter its system of moons and potentially influence the surrounding space environment.
So if Uranus crashes into Jupiter, would that throw the entire solar system into chaos? Could Earth be affected?
Actually, if Jupiter's structure were altered due to such a collision, it could indeed have some effects on the solar system as a whole. But for Earth specifically, it wouldn't cause any immediate catastrophic consequences. Jupiter is often referred to as the gravitational guardian of the solar system. Its immense gravitational field acts like a natural shield, attracting and deflecting many comets and asteroids that might otherwise pose a threat to Earth. This protective role helps Earth maintain a relatively stable and safe orbit. If Jupiter's internal structure were to change from the impact, it could lead to subtle shifts in its gravitational field. This, in turn, might affect the orbits of smaller bodies in the solar system. Such changes could cause slight deviations in the paths of comets and asteroids, and in some cases, these objects might even be pulled into new orbits due to the gravitational disturbance. However, Earth's orbit is highly stable and strongly governed by the Sun's gravity, so it wouldn't be directly affected by these small shifts. Of course, over the long term, structural changes in Jupiter could gradually influence the gravitational balance of the solar system. This might result in minor orbital adjustments for some planets and objects over millions, or even hundreds of millions of years. But these changes would be part of the natural evolution of celestial systems, not sudden or catastrophic events.
You mentioned earlier that Uranus has a strange rotational axis. It's almost lying on its side as it spins. What's going on there? Could that also be the result of a collision?
Exactly. Uranus's rotational axis is tilted by about 98 degrees, which means it's almost lying flat relative to the plane of its orbit around the Sun. This is extremely rare in our solar system. Scientists believe this unusual tilt is likely the result of a massive collision billions of years ago, possibly with an object about the size of Earth that slammed into Uranus at a very high speed, essentially knocking the ice giant onto its side. This colossal impact not only shifted Uranus's axis of rotation, but also drastically altered its climate and seasonal cycles. Because its axis is nearly perpendicular to its orbital plane, each of Uranus's poles experiences over 20 years of continuous sunlight or darkness as it orbits the Sun. In other words, Uranus's summers and winters aren't a few months long like on Earth. They can last for decades, leading to extremely unusual and extreme seasonal phenomena. This dramatic tilt and the resulting seasons make Uranus's climate behavior completely different from that of Earth or any other planet in the solar system. Its north and south poles take turns being exposed to long periods of sunlight, causing intense temperature contrasts and unique weather patterns. This has sparked strong scientific interest in Uranus's internal structure and atmospheric dynamics, as researchers work to uncover the mysteries of this icy, tilted giant.
Wow, so if Uranus actually crashes into Jupiter, would Uranus's sideways tilt affect the way they collide?
Absolutely. The angle and direction at which Uranus hits Jupiter will directly shape the dramatic outcome of this cosmic collision. When two giant gas planets meet, The manner of their impact influences not only the energy released, but also how their materials merge or scatter. If it's a head-on collision, it would be a universe-scale all-out showdown. The gaseous outer layers of both planets would violently compress and merge, instantly releasing massive amounts of energy and forming an even larger, more complex gas giant. This kind of collision would redistribute energy and materials inside Jupiter, causing intense turbulence and structural changes. Jupiter might become bigger, but also more unstable, with its overall magnetic field and rotation speed potentially altered. On the other hand, if it's a sideways collision, the scenario is completely different. This impact wouldn't produce such a fierce explosion. Instead, a vast amount of gas would be forcefully ejected, creating a colossal gas storm in space. Under such an impact, Uranus's outer gas layers could be stripped away, exposing its solid core. This stripped core, like a bare planetary nucleus, would drift alone alongside Jupiter's gaseous envelope, becoming a new kind of celestial object. These two very different types of collisions reveal the delicate interplay of forces and matter in the universe, allowing scientists to use simulations to better understand planetary structures and evolution. Whether a direct fusion or a sideways stripping, this collision will change the fate of both planets and could even impact the dynamic balance of the entire solar system.
So how many moons does Jupiter have? Would they be affected by the collision?
Jupiter is currently known to have over 80 confirmed moons. The most famous and largest are the Galilean moons, Io, Europa, Ganymede, and Callisto. These 4 moons are not only huge in size, but also possess unique geological features and potentially subsurface oceans, making them key targets for scientists exploring the solar system. However, if Uranus were to actually collide with Jupiter, this violent cosmic event would have an unprecedented impact on Jupiter's satellite system. The massive gravitational disturbances and gas storms triggered by the collision would severely disrupt the orbits of these moons. Their previously stable paths could be thrown into chaos, and the gravitational relationships between the moons would become highly complex. In this chaotic gravitational environment, some moons might be violently ejected from their orbits or even flung out of Jupiter's gravitational influence, becoming lonely, wandering bodies. There is also a possibility of moons colliding with each other, causing a kind of moon chaos. Such collisions would generate large amounts of debris and dust, further increasing instability within the entire satellite system. Additionally, the gas storms and shock waves caused by the impact would affect the surface conditions of the moons. For example, Europa's icy shell might develop cracks due to seismic shaking, intensifying activity in its subsurface ocean and adding new variables to the search for signs of life. Moons like Ganymede and Callisto could also experience large-scale geological changes, significantly altering their appearances.
What about Uranus? Does it have moons? Is there a risk that some might be picked up by other planets?
Uranus is currently known to have 27 moons, which is relatively few compared to Jupiter's more than 80 moons. However, this doesn't mean Uranus's satellite system is completely stable. Scientists speculate that when Uranus passes near Saturn's orbit, there's a possibility for Uranus to borrow or snatch some of Saturn's moons, adding these small bodies to its own collection as new members. This phenomenon is actually quite common in the universe and is called moon capture. It occurs mainly because of the delicate gravitational balance between Saturn and Uranus, which can destabilize certain moons caught in the gravitational tug-of-war between the two giant planets. These moons may eventually break free from their original planet and be attracted by the other, becoming new satellites. This dynamic interaction showcases the vitality and constant change within planetary systems. Moon capture not only enriches Uranus's satellite system, but also provides valuable insights into gravitational influences between planets. When Uranus picks up moons from Saturn, these captured moons may undergo orbital adjustments and even changes in surface structure, making them excellent subjects for studying astronomical dynamics and planetary evolution.
Hearing you say that, it sounds like the planets in the solar system are dancing, fighting, and yet like friends. It's fascinating. If I were to imagine the moment of the collision, what would it look like?
Imagine, against the dark backdrop of space, two massive celestial bodies, one glowing with a mesmerizing blue-green aura, the other wrapped in a dazzling orange-red gas layer, slowly approaching each other. Around them swirl countless moons and drifting cosmic dust, serene yet tense. As the distance between them shrinks, these two giant gas planets begin to enter each other's gravitational influence, and a magnificent cosmic collision is about to unfold. At the moment of impact, their thick gaseous outer shells are violently compressed and torn apart, with their gas layers bursting outward like exploding balloons. Instantly, scorching gas storms form, with gas jets shooting out from the collision point at incredible speeds into deep space. Temperatures skyrocket to thousands of degrees, and brilliant light flashes with destructive power. For that moment, the entire universe seems to freeze, presenting a breathtaking and awe-inspiring spectacle. As the intense shock waves fade, the two planets gradually merge into a massive, irregularly shaped new celestial body. Its magnetic field fluctuates wildly, producing strong electromagnetic waves, while dense gas clouds and debris swirl around, like a dynamic cosmic painting unfolding before your eyes. This grand planetary fusion not only rewrites their existence, but also reshapes the environment of the surrounding space.
So, does that mean the collision isn't like an explosion shattering everything in a movie, but more like a gentle impact of compression and fusion?
You could say that, but the term gentle is relative to human perception. On the cosmic scale, such a collision involves extreme compression and drastic changes, with energy release far beyond what we can imagine. However, it's not like the colorful, fiery explosions we see on Earth. Instead, it's more about gases, heat, and matter being squeezed and mixed under extreme conditions, a grand physical phenomenon unfolding in silence. When two gas giants collide, their thick gaseous envelopes compress each other, and their cores undergo intense pressure and deformation. There are no burning flames, but countless jets of superheated gas, and debris form fierce and violent gas storms. While this power lacks the dazzling visual effect of fiery explosions, its intensity is enough to alter the planet's structures and even reshape the gravitational balance of the entire planetary system. This cosmic scale compression and mixing make the fusion of gaseous bodies possible. Gas molecules are forced to interpenetrate, temperatures rise sharply, and complex magnetic field variations occur from interactions between materials. This process is like a gentle symphony in the universe, order and reorganization hidden within the ferocity. It's not only a display of physical phenomena, but also an important window for astronomers to study planetary evolution and cosmic dynamics.
I've heard that if Jupiter were a few times heavier, it could become a star. Is that true? If Uranus collided with Jupiter, would it make Jupiter turn into a star?
In theory, Jupiter would need to be about 13 times its current mass to become a brown dwarf, a mysterious object between a planet and a star. To actually become a true star, Jupiter would need roughly 85 times its current mass to ignite nuclear fusion and shine by its own light. However, Uranus's mass is only about 1/20th that of Jupiter, far too small to cause such a dramatic increase in Jupiter's mass. Therefore, if Uranus were to collide with Jupiter, there's no need to worry about Jupiter instantly becoming a star. Although the impact could increase Jupiter's size and heat energy, it would still be very far from the conditions needed to become a star. In fact, this collision would more likely stir things up inside Jupiter, triggering intense gas turbulence and energy redistribution, possibly causing large-scale gas eruptions and magnetic field changes. But Jupiter would remain a massive gas giant, not a star. As the largest planet in the solar system, Jupiter's immense gravity and mass have long served as a gravitational guardian, protecting Earth from threats like meteoroids and comets in space. Even after such a collision, Jupiter would maintain its stable orbit and gaseous nature, although its structure might become more complex and spectacular.
After the collision, will there be any changes in the solar system? For example, could Earth's orbit or climate be affected?
When Uranus and Jupiter collide violently, Earth won't feel any obvious effects in the short term, but the gravitational field and the orbits of small bodies within the solar system will undergo subtle adjustments. Jupiter, as the most massive planet in the solar system, has long maintained the stability of nearby small bodies' orbits with its powerful gravity, preventing many comets and meteoroids from striking Earth. However, the collision will cause a redistribution of mass and release of energy, inevitably altering Jupiter's gravitational distribution and triggering slight changes in the orbits of surrounding bodies. Although these changes won't bring catastrophic events to Earth in the short term, from a long-term perspective, the orbits of comets, meteoroids, and even other planets within the solar system could be reshuffled. The trajectories of small bodies are extremely sensitive to gravitational forces, and even slight changes may trigger chain reactions that push them off their original orbits, increasing the risk of impacts or altering their gravitational interactions with planets. Moreover, the overall gravitational balance of the solar system may undergo a significant adjustment. The gravitational pulls between planets mutually restrain one another, maintaining a stable orbital order. This dramatic collision between Jupiter and Uranus is like a reshuffling of the deck, potentially affecting the dynamic equilibrium of other celestial bodies in the solar system. This not only serves as an important case for scientists studying planetary formation and evolution, but also reminds us that while the cosmos appears stable, it harbors underlying potential turbulence and change.
It sounds like this cosmic scale collision is not just an astronomical event, but also a turning point in planetary evolution.
Exactly. The history of celestial bodies in the universe is actually full of stories of collisions and mergers. From the dusty clouds at the birth of planets to the magnificent planetary systems we see today, countless violent impacts and combinations have shaped the cosmos as we know it. These collisions are not just destructive, they are processes of creation and rebirth, constantly evolving the structure, composition, and orbits of celestial bodies. By studying these impacts, scientists gain deep insights into planetary formation and evolution. For example, Earth's moon is believed to have formed from debris ejected after a Mars-sized body collided with the early Earth. Similarly, Uranus's extreme axial tilt may have originated from a massive ancient collision. These events reveal how planets continuously absorb material and restructure themselves in the chaotic early universe to eventually become the stable bodies we observe today. More importantly, these collisions help us understand the solar system's evolutionary history, from the dust in the primordial nebula to the formation of a planetary system, and then to the dynamic gravitational interactions between planets. Every step carries traces of collisions and mergers. This knowledge not only informs us about the past, but also enables us to better predict the solar system's possible changes and development trends in the future.
Speaking of the future, when would such a collision happen? Could I be alive to witness it?
Rest assured, the probability of a collision between giant planets is extremely low. These astronomical events usually take millions of years or even longer to occur. Based on current scientific observations and astronomical data, both Uranus and Jupiter are steadily orbiting along their respective paths, with no signs that Uranus will deviate and collide with Jupiter. This means there's no need to worry about such an impact happening anytime soon. Scientists continuously monitor the major planets and their orbital changes through precise telescopes and computer simulations, ensuring they can promptly detect any unusual movements. These studies confirm that the orbits of Jupiter and Uranus are very stable, regulated by the gravitational balance of the Sun and other planets, which prevents them from coming dangerously close to each other. More importantly, collisions of massive planets like this are extremely rare cosmic events, often used by scientists as hypothetical scenarios to explore theories of planetary formation and evolution. While simulations can imagine the consequences if such a collision did occur, in reality, it's more of a future research topic for scientists than a threat to our current lifetime.
Then let's keep using simulations and imagination to experience this cosmic storm. Today's detailed and fun sharing made me feel like I've been traveling through the universe. Don't forget to subscribe, like, and leave a comment, so we can keep enjoying this journey together. The stories of the universe never end. Let's explore the infinite possibilities of the stars and the seas together.